Let's go ahead and jump onto our lab environment and do a demonstration of RIP version 2's configuration. Let's go ahead and begin our demonstration here of just the basic RIP version 2 setup by taking a look at the configuration. This is what our lab topology is going to look like for this example. We're going to start out with just a simple RIP2 domain. Now, the switches that you see in this topology are not entirely relevant. What we have here is essentially R1 connects to the ASA and to router 2 over VLAN 10. The ASA then has an inside interface, which is VLAN 45. R2 has a number of loopback addresses that will be advertised into the RIP domain. And then router 1 on its fast Ethernet 0/1 is VLAN 100, and that's where we see that server configured. So we've got a couple of different things here in the topology that we'll be able to ping between, but we're going to start out this demonstration by just going to router 1. On router 1, we're going to enable RIP version 2, and we're going to enable it for both of our inside and outside interfaces, or rather for VLAN 100 as well as VLAN 10. Let's go ahead and go on over there to our router 1 command line. Okay, so on router 1, first thing that we're going to do is enable RIP. We're going to set it to use version 2. And then we're going to enable it for our, we're going to use 198.51.100.0. We're also going to enable it for VLAN 10, which is 172.16.10. So we'll do a network statement for that. And we're also going to give it the no auto summary command and make sure that we're not summarizing at the classical network boundary. Okay, so that's really all we need to do right now on R1. Now let's go back to the topology. And in this topology, we can see we now need to enable RIP on the ASA as well as on R2. Now the ASA configuration is going to be a little bit different than what we saw in the slides there, but nothing that's too far out there that you shouldn't be able to keep up with it. In fact, you probably already know it because really this type of material is a review for a CCIE candidate. But let's start with R2 and then we'll move over to ASA1. And here we are on R2's command line. So same thing, we're going to configure RIP with the router RIP command. We're going to give it the network command for 172.16.10.0. We're going to give it version 2. And we're also going to give it no auto. And that should be enough at this point to at least get the 198.51 network from router 1. Let's see if we have that so far. Okay, so we can see from the output of this show IP route command that we do in fact have 198.51.100 from the router 1 advertisement. Okay, but another thing that we noticed, let's take a look at our interfaces. Okay, we don't have our loopback interfaces configured on here, so let's configure those loopback addresses so that we can bring those into RIP. Loopback 1 is going to be 10.0.101.1. I believe we're doing a 24-bit mask on that. Interface loopback 2 is going to be 10.0.102. Loopback 3 is going to be 10.0.103. Loopback 4, we'll give it 10.0.104. And let's do one more. Interface loopback 5. And we're going to give it 10.0.105.1. Okay, and then we're going to go back into RIP. We're going to add the network 10.0.0.0 command, which will then bring all 5 of these 10 networks into the RIP routing process and advertise those over to router 1. Let's go over to router 1, and on router 1 we'll issue a show IP route command. And now we can see we've got all those loopback addresses that are coming across from router 2. So far so good. Very simple RIP configuration. The next thing that we want to do is configure our ASA for RIP. So let's jump on to ASA 1. And on ASA 1, let's just look at the interfaces. Okay, so we can see that we have VLAN 10 and VLAN 45. VLAN 10 is our 172.16.10 network. VLAN 45 is our inside network there, 192.168.45.13. So we're going to advertise that. We'll assume that we're not going to be doing NAT in this, so we want that address to be advertised. So that's one of the things that you need to consider when you're configuring a routing protocol on your ASA, and really even on your routers for that matter, is if you're doing network address translation, then the address range or the network may not need to be advertised. In this case, we're going to advertise it. So I'm going to issue the router RIP command, and you can see that takes me into a config-router, which is kind of what we expect to be in. We'll turn off auto summary because the ASA does that by default as well. And we'll give it the network command. We don't need to give the 127 network a network statement because that's a virtual interface that's used internally by the ASA to transport data across the data plane. So, or I'm sorry, across the backplane. So we don't need to add that. It's not actually part of our routing process, but we could also do a question mark here. And you notice we have the option to set the routing protocol version. That's also what we want to do here. We want to set it to version 2. And then let's go ahead and look at our routing table and see if we've even received routes yet. So on our ASA, remember it's just show route rather than show IP route. And we've got the 198.51 network, and we have all those 10 networks. Now there is a server at 198.51.100.100, and we can see that in the topology. So if routing is functioning as expected, then from our ASA, we should be able to ping that server. Let's test that. And we have a successful ping across the network. So at this point, we have RIP routing successfully configured. We can verify it, like I said, with that show route command on the ASA and show IP route on router 1 and router 2. Additionally, you might be interested in the debugs. I'm not going to go into those here. This should be somewhat of a review, and we'll actually look a little bit at debugs when we do our authentication.